Good afternoon or good morning, depending on your time zone. Welcome to the Synerzip webinar series. I am Ranjani Shah, a product manager at Synerzip. Before we get started today, I'd like to cover some housekeeping items. During this webinar, feel free to ask any questions through the chat box on your GoToWebinar window. We'll try to get to all of them as appropriate. The webinar itself will run about 45 to 50 minutes. Then we will reserve the last 10 minutes to address all your questions. Please note that the webinar is being recorded. Tomorrow you will receive an email with a direct link to the recording and slides. So with that covered, I'd like to introduce today's topic, which is Hadoop or Hadon't, as in the title. So until now, most people have used, many people rather, have used Hadoop for its advantages. However, developers and users are realizing that Hadoop has its limitations. It cannot combine all data effectively and provide performance with ease of use. Customers are deploying modern alternatives like Snowflake to combine semi-structured and structured data effectively and provide quicker and easier access to data for the analyst community. However, the advantages of Snowflake go even further. It allows customers to ingest and query semi-structured data effectively using SQL, making it easy for analysts to use rather than be dependent on development of complex MapReduce tasks as in Hadoop. Another advantage is the need for managing the environment and security because of the cloud nature of Snowflake Elastic Data Warehouse Service. And lastly, but not the least, Snowflake allows developers and analysts to use JDBC, ODBC, R, and Python to develop applications on top of Snowflake. And so let me introduce today's speaker. Today's speaker is Saqib Mustafa at Snowflake. A little bit about him. Saqib currently works as Director of Product Marketing at Snowflake. He's worked in numerous other roles in the past, including Cloud Data Warehouse, a sales partner in North America, a program sales manager for storage, server, and virtualization, a cloud product manager as a cloud product manager and on data center products and professional services delivery. He's been part of organizations like Teradata, CDW, Shell Oil worldwide. With that, over to you, Saqib.
Thank you, Ranjani. And thank you very much for Synerzip for giving us the opportunity to talk to your audience today. Greatly appreciate the introduction and the opportunity. So before we go into the challenges of Hadoop, let's talk about what Hadoop is used for today. Hadoop today provides a repository for easy data loading. Typically, you have to do no pre-processing of the data before loading it into Hadoop. It can easily scale up. However, there are issues in scaling down. It can be used to pre-process some of the data for more expensive data warehouse environments, which helps in doing some of the ETL before the data warehouse itself. It can also be used for short-term projects and to store historical data, typically beyond 3 years. That's the industry standard which it's used for. However, we have to keep one thing in mind, that Hadoop was never created for analytics itself. It was created to solve search engine woes for companies like Yahoo. And it's a 10-year-old technology, an open source technology. And considering that time frame, we believe that it lacks maturity and consolidation of the data. So what are the challenges of Hadoop? Well, it is inefficient at processing structured data. And it was built for basically storing semi-structured data. However, even today, most of the revenue and cost information still comes from structured data sources like CRM systems like Salesforce. for example. It is also very difficult to secure Hadoop environments. And the platform provides almost no access control, which means that a lot of enterprises are not using it because they're security conscious. Then there's the complexity of use. It is complex to use from the perspective of analysts, for example. You still have to write MapReduce jobs, which create dependencies on the likes of IT. Now, some might say that, well, Java resources are easily available. But typically, these lie under IT and not under the analysts. So you still have to rely on these resources to do the Java programming. Now, with the likes of Hive and Presto, this has been reduced somewhat, but the dependencies still remain. And then for Hadoop, Hadoop cannot perform analytics at a scale. The platform does not support workload management, and it actually serializes workloads. So if you have 50 users querying the platform, you're serializing 50 users. The 50th user has to wait. So what are today's realities? Today's realities are that data is coming from multiple sources, not just enterprise apps, but it's coming from third-party resources. It's coming from Internet of Things. It's coming from the web. And they're different, very different sources. They're very differently structured. The thing is that you're still getting CRM and enterprise apps typically providing data to data warehouses, while machine data or weblog data is going to the Hadoop or NoSQL systems. And both of these are complex and costly infrastructures to maintain. Plus, there's no one environment to combine all of this data in together, which means what? That you end up creating data marts, which is that you're storing data in multiple copies of that same data. And you have multiple versions of it, which is even worse. And all of this leads to barriers to insight. Analysts are slowed down, and the data pipeline itself becomes a roadblock. Now, how silly is this? That the very process designed to create value has become the roadblock in creating value for the business. So considering NoSQL systems like Hadoop or MongoDB or Cassandra, right, they're typically very complex. They rely on tools like Java and MapReduce, and you need new skills. They don't scale in terms of performance of analytics. They typically have an incomplete patchwork of tools, incomplete SQL support. And then security is a major concern for enterprises, where they're not able to develop secure solutions for these environments. And then there's open access to these environments, so there's almost no user access control. On the flip side, though, for secure environments, data warehouses and stuff, or legacy data warehouses, they're very costly. They're very complex, and they're inflexible. They don't accommodate the semi-structured data, the machine data, the weblog data, which Hadoop and other environments can do easily. So what are we looking at? We're looking at some unaddressed use cases here. We're looking at the ability of platforms to be able to combine semi-structured and structured data together to present one view of your organization. You're looking at the ability to do exploratory and ad hoc analytics easily from analyst perspective, because frankly, analysts use SQL, and they want to be able to do analytics on something really quickly, rather than relying on somebody in IT to do it for them, or write a job for them. And then at the end of the day, again, this goes back to having the one single version of all your data, the data mart consolidation. You have to consolidate all the data so that you can eliminate the length of the pipeline itself. And imagine that, for example, if your marketing data was different from your social media data, was different from your e-commerce data, how painful would that be? Well, in that case, Snowflake came in with our vision that we wanted to reinvent the data warehouse. We wanted the capabilities of the data warehousing and the ability to do performance and enterprise level capabilities using SQL, right, or SQL. And we wanted to connect to the existing tools in the existing ecosystem of BI and analytics. We wanted to be able to provide an interface to also incorporate big data. The data such as machine data, such as weblog data, data from data formats as in JSON, Avro, and XML, and to be able to incorporate that in a cloud-like environment where we are able to provide elasticity and agility to this whole environment, and to be able to do it in a service, not as a platform, but as a service. So what did we build? We built a completely new SQL data warehouse from the cloud up. We did not use anyone's legacy code. We did not use anyone's legacy platform. We built it from the ground up for this purpose. We built it for the cloud, so it's highly elastic and scalable. We deliver it as a service, so frankly, you don't have any infrastructure to manage. You don't have any knobs to tune. You don't have any data warehouse management headaches. It just gets done. There are no indexes to manage. This is all just done in the background for you. Your queries are optimized, and our service just does it for you. You just write the query and drive business value. And all of this, all your data, machine data, weblog data, semi-structured data, all of this is in one place. That is the promise, that give you one view of your entire enterprise's data or your entire organization's data. So you can see one picture. Now, how is that typically different from a traditional data pipeline? Well, it's different because if you look at a traditional data pipeline, let's say you get machine data or weblog data from Internet of Things or from the web itself. Now, typically what will happen is you'll do some pre-processing in Hadoop or NoSQL systems like MongoDB or Cassandra. You'll convert it into a CSV file, then you'll load it into a data warehouse or a data mart, and then serve it out to your analysts. And as you can see in this example, there's a JSON file coming in from Twitter, which has my name on it, which has the city and the school and the college I went to. And it gets converted into a 3-field CSV file in a NoSQL system, and then it gets inserted into a table. Well, we believe that all of these are extra steps, and that the customer should not, or any organization working on this should not be doing these steps. And that if you consider this, right, if you look at this, there are 3 fields coming in. What if there were 15 coming in tomorrow? Well, then would you have to change the whole process? And it's pretty well known that, from multiple sources you'll get JSON. Like, for example, when you're doing customer analysis, you might get data from the customer from Facebook, from Twitter, from Google, and this might be related to customer sentiment. And in that, there are different sources of JSON which are coming in, and they might have different fields populated. Well, will you have to change the process every time you incorporate a new feed? That is some of the challenges which a traditional big data pipeline presents to us. Well, how does Snowflake do it? Snowflake just directly ingests the data into this data type called variant. So you can see the tweet example here on the left-hand side gets ingested into this one table directly called the variant data type. And using the power of columnar-based database, we are able to store the whole thing in 3 fields. Now, let's say the feed changes and becomes 15 fields. Well, Snowflake automatically divvies it up into 15 fields. The user themselves does not have to do any of it. And you can also, at the end of the day, optimize your queries to it. You can write simple queries to query it, as you can see the select statement on the right-hand side. So you directly ingest data into the table. There are no changes that are required. And for any change to the data set, you don't have to do anything. Snowflake automatically adjusts to it. Plus, you get the advantage of using standard ANSI SQL, which most analysts know, and which most BI tools know. So you can easily derive from there. Now, architecturally, how are these two environments different? Well, Hadoop and NoSQL systems or some data warehouses are shared nothing decentralized storage in a single cluster. There are some drawbacks to this. You cannot easily do workload management. You cannot easily share the environments between different departments. For example, for test dev, you will have to replicate the data itself, and you'll have to create multiple copies of it. Well, Snowflake is actually multi-cluster and shared data warehouse. Shared data. So in Snowflake, the centralized storage stores all your data, while you can declare multiple clusters of warehouses for test dev, analysts, for sales, for others in your organization. So you still get the single version of the data for everyone, and while you have independent compute warehouses for everyone. So you can share the same data across the board.
Saqib, one question
Sure.
Here. Do you have an idea? You mentioned unstructured and structured data. Is there a percentage of all the data that exists, let's say in the city of Dallas or anywhere? Is there a percentage of data that's unstructured versus structured?
Yeah, so that's a very good question. And there's no specific percentage. However, what we are seeing is a couple of things. For example, first of all, I was just talking to a customer yesterday, and what they're doing is they brought in their structured data first, but now because of Snowflake's abilities to incorporate semi-structured data, they're going to bring in more semi-structured data. I was talking to another customer who's doing both, and they actually have a 90-10 percentage. So 90% of their data was structured, while 10% of their data was structured. And that's typically the case in an organization because there's a lot more sources of semi-structured data, like the web logs, like Internet of Things, like sensors and stuff, things like that, which generate a lot more data in terms of actual amount of data. Now keep in mind that a weblog includes every click, every action a customer is taking on your website, for example. Now every click in itself is not important. However, when you combine all of them together, it tells you the customer experience on your website, which is very important, right? While on the structured data side, you have transactional data, which in itself is very important because you know what the customer is buying, what the customer is selling, what the customer wants, how they're interacting with your transactional system. So there's a value attached to the level of data. However, it depends from customer to customer what data they're bringing in. We are seeing 90-10% in a lot of customers. So I hope that answers the question.
Yes, definitely. I have a couple of questions that have come in on from the audience. And it is actually on slide 11. Are the multi-clusters same as data marts?
No, so the multi-cluster is not the same as data marts. And you have to keep in mind that for data marts, they don't have a shared storage, right? So in a data mart, they're basically sending out the data and replicating the data across different data marts. In this instance, for example, we are just creating warehouses. So this test dev is a warehouse as a compute resource. It's not the actual data. The data itself is still kept in one shared location. So the data itself is not replicated. You can have different compute instances for analysts or sales or dev or data loading and stuff. So very different from a data mart concept. Ranjani, does that answer your question?
Yeah, it came from an audience member.
Okay.
Go ahead. Thanks.
Okay. So talking about a little bit more about the architecture itself. Well, what does the architecture enable us to do? It enables us to do very strong concurrency across the warehouse and enables us to scale concurrency across the warehouse. So we have what's called the cloud services layer, which basically manages, optimizes, provides security, and manages the metadata. And this is where you connect through the ODBC, JDBC, and all the connectors. And there's a single database storage, which is centralized. Like the person who just asked the question, it's not like the data marts because we are not replicating the data itself. And then you can have different warehouses for loading, ad hoc BI, development, whatever you need in terms of if you want to push it out to sales. What this does is, so for example, today you are developing your warehouse and it's limited to 10 users. Then tomorrow you want to serve it out to 30 people in marketing. You spin up another compute warehouse and you give access to the marketing folks. You have to stop your loading. You do not have to stop your analysts or any of your development. Then a year from now, you want to push it out to your 5,000 people sales team. Well, spin up another warehouse. The data store is still the same. And so it enables you to do rather large scaling in terms of concurrency and helps you design your whole environment that way. Now, let's say if you wanted to cut down on your users, you can also spin down those warehouses really easily and enable your whole environment that way. One of the things which I love about Snowflake, and this comes from a very passionate background in analytics, is the fact that in Snowflake there are no infrastructure, there are no knobs to turn, no nothing, no tuning to do. I was just talking to a customer yesterday, and they had compared how they had built an environment for Snowflake versus Hadoop versus a legacy data warehouse. And they said that their environment in Snowflake started running within a week. Well, for Hadoop, it just took 3 weeks to get started. And then on top of it, the type of performance they were getting was 300 times the performance of an existing Hadoop platform. And all of this comes from the fact that there's no infrastructure to manage, there's no data storage to manage, there's no metadata to manage, there's no manual query optimization. All of this is done for you. All your analysts have to do is to write a SQL query or attach it to their BI tool and start working through it. Now, keeping in mind that Snowflake has to exist in an ecosystem. We are part of a larger environment where analysts and BI and data management folks work. And so for getting data from diverse data sets to actually getting them transformed into Snowflake, you can do it directly or you can use any of our partners. We work with multiple partners on the BI side too, like Qlik, MicroStrategy, Tableau, R, Excel, Looker, and IBM Cognos. You can connect to us, like you said, Ranjani, through JDBC, ODBC, scripting, Python, even Spark connectors. Some of the people using machine language data or are working on a lot of machine language data use Spark connectors to connect to our environment. And it's very beneficial to them. And all of this exists in an environment where we are able to use folks like Synerzip, for example, to be able to deploy Snowflake for our customers. And it's interesting because our conversation with Synerzip began because of the fact that one of our customers, who's in the healthcare industry, and wanted to build a service on top of Snowflake. So Synerzip and Snowflake work together to deploy this service. They're not only using it for the internal analytics, they are going to ship this service out to 11,000 potential retail outlets with healthcare information to do this. And that is how we exist inside the ecosystem.
Saqib, can we stop for
Sure.
A few questions, lots of questions actually from the audience.
Absolutely.
I don't know if this might make more sense towards the end, but one of the questions, and it's another person asked, how do you differentiate yourself from Amazon Redshift? And along the same lines, another audience members asking, it sounds similar to Azure Data Lake concept. Is that a right statement?
So those are very relevant questions, right? Let me state this out again. We did not build any of our environment on top of an existing platform or any existing code. We work very actively with our partners. However, we built this environment completely for ourselves. And from the data lake concept, I mean, frankly, the ability to combine structured and semi-structured data is significant. Data lakes are typically meant for storing semi-structured data, but not querying it effectively. structured data cannot be combined effectively in them too. While here, what we are doing is we're combining structured and semi-structured data together in one environment. In terms of competing with others, we have seen significant performance improvements compared to other legacy data warehouses, whether they're in the cloud, whether they're in the on-premise. I mean, we run against all sorts of competition. And what I'm really proud of is the fact that we beat competition by, I just talk to customers and they tell me, we're seeing 200 to 300 times performance improvements, right? So without actually mentioning any of the competition, when we look at what customers are doing with our data and what sort of queries they're running, it's just great. And then the whole point is that ours is actually a service. It's not just a data warehouse platform, it's a service. So you don't have to do any of the tuning, any of the work. And when you need to scale it, you can automatically scale it by pressing one button. And you can have the whole structure go from a medium-sized warehouse to a large-sized warehouse. Let's say you're an analyst and you're writing a query at 5 p.m. and you want it to finish so you can go home and see your kids on a large. So all you have to do is you run it on a large server, get it done, and close it out. That is not possible in a lot of the legacy cloud platforms to scale that efficiently. In fact, this is the funny part where a lot of our customers appreciate the fact that when they're working 9 to 5, they can turn off some of their warehouses after 5 p.m. and save a lot of money compared to other environments which do not allow them to do that. So I hope that answers those questions. Any other questions, Ranjani?
Yes, there are quite a few questions. Along, sure. You mentioned an analyst going home, after starting off the job. So one of the questions is, you say it's based on SQL, but that seems to be geared towards querying and not developing. Are there any plans to extend the SQL capability to include cursors, stored procedures, variables, etc.?
Yeah, so we do have plans to do that. And for the perspective of the development community, I mean, we have ODBC and JDBC connectors. We are extending into, we have Python connectors, and we are building more scripting capabilities into our platform. So yes, absolutely, we want to cater for our development partners. We want to cater for those who are connecting not only through SQL, but through Java or other tools. I think I'm not allowed to go into too much detail, but sharing with our partners, we are looking at JavaScript and stuff too. So absolutely, we have plans to develop that more and more, and we are enabling that through our connectors too. And you can actually, there's a very good article or blog which was written recently by one of our product managers about our connectors, Python and R. So you can go look at our website on that too.
Okay. I think in the interest of time, I guess we should move on with the presentation. We'll get to the questions in the end, for sure.
Okay. But great questions, great participation. I love this. So from our perspective, you have to keep one thing in mind, that when you talk about enterprises, when you talk about customers, when you talk about customers like we've worked with Synerzip, who are healthcare customers, security is paramount. It is very, very important. Nobody trusts a cloud environment without the security of a very high-level service. So we provide authentication, multi-factor authentication, federated also available. Access control for role-based access is available. Data encryption from end to end is always enabled. Encryption keys are managed for you automatically. And then on top of it, as validations, we've gone through certifications like SOC 2, Type 2, and HIPAA. So that actually helps us in terms of presenting this whole thing to customers and saying, look, our environment is HIPAA compliant. Our environment has all these partners who are working with us to develop the offering. And then on top of it, we have customers who are trusting us and partners like Synerzip enabling us to do this. And this is one of those things which really differentiates us from the likes of Hadoop, for example, because it's very difficult to secure a Hadoop environment. Hadoop actually is one of the most painful environments to secure, and this is one of the complaints which we are going to talk about later on, is in one of the scenarios for our customers, what used to happen was because of lack of access control, imagine if they had a 100-node Hadoop system and on node 51, somebody jumped up and started writing a script and this, started running a job which would basically hamper all of the resources. This is a real example from our customer, Ask.com, who we're looking into, who had a Hadoop system, who had a data warehouse system, and this presented a major challenge to them. So Ask.com is an interesting example because basically they've grown through acquisitions. They've bought companies like Investopedia, OkCupid, Dictionary.com, and they keep on buying companies because frankly, they're competing in a space where they have behemoths like Microsoft, Bing, or Google, right? They cannot directly compete with those guys, so they tend to buy smaller companies and compete in that perspective. And it's a very interesting model. What they want to do is analyze and monetize large sets of data across different websites. So they have different websites like Us.com or About.com or Investopedia where they want to monetize that data. Well, the pain points they had is that they had a 100-node Hadoop system. They had a 36-node data warehouse system, so two different systems. On top of it, they had large data volumes of traditional and JSON data coming in. They had no single version of the truth itself. And then there was unpredictable performance on both the data warehouse and the Hadoop system. So, and because of the sheer size of their data warehouse and Hadoop system, they really did not have a true dev test system. They could never replicate that size of their data for dev test and test it out. And now, talking to the development community, you all know what happens when you have no dev test environment. It leads to a lot of problems. It leads to updates in the production environment. So from that perspective, what they did was they deployed Snowflake. And they load all their data into one Snowflake warehouse. They load all the JSON data and traditional data from different sources. And they're getting multiple feeds. I mean, they're getting feeds from different websites. They're getting feeds from customer sentiment feeds from different providers too. And they're able to build all of that in one environment and easily load JSON, like the example we showed to you before. And then they have native connections from Tableau, and they also use JDBC to connect to other more development-based platforms. And they're able to basically use a Snowflake feature which is called cloning to really just clone the whole environment and provide a dev test environment. And whenever they want to clone it, they just press two buttons. They just write a query. It clones the whole environment really quickly and provides a dev test platform to the dev test team and say, hey, here you have it. And that's a feature they use very actively. And what cloning does is it doesn't replicate the data in the background, but it provides basically a pointer to the data itself to the dev test people. And that way they can use it very effectively. Now imagine every time you wanted access to the production data, you could get it. You didn't have to copy it. You didn't have to back it up and restore it somewhere. You didn't have to create a whole new environment every time. You just wrote a query and it got the data replicated or the cloned, and you would be able to do it. This is why, their BI directors is saying that, hey, we turned from a cost center to a value center, and they're providing value to their original business. So that's how we're doing it in the ad tech space. This is weblog data, this is machine data being used. Now, from the Snowflake perspective, I mean, this is just one of those slides which, shows the diverse customers we have. And the more and more customers we are starting to see who are coming into the space and saying, look, we want semi-structured data to be combined with structured data in one environment, and the flexibility of being a service. Just to recap at the end, Snowflake is an all-new data warehouse. It's created for the cloud, but it allows you to combine structured and semi-structured data in one place, all of it together, and delivers one place for all your diverse data with easier, faster analytics, elastic scaling so that you can meet your concurrency requirements. You can serve it out to multiple users in your environment, serve out workloads, data, and without the cost and complexity of platforms like Hadoop. You don't have to write any more Java jobs. You don't have to manage the whole environment. You don't have to scale it. You just write your queries. You just design your Java programs connected through JDBC and serve it up. And Snowflake does the rest. So with that, Ranjani, let's take a break and let the audience ask him more questions, and we'll take it on from there.
Yep. Right now, in fact, we have a lot of questions from the audience.
Okay,
which is
great.
Wonderful. So what I'll do is, I want to see if there are any common themes. So I'll just give them a couple of minutes to, come in. So meanwhile, while we're, waiting for more questions, I just wanted to talk a little bit about SynerZip itself. SynerZip operates as a partnership with our Saqib, if you can advance to the SynerZip slides in your deck. One more. Yeah. So we work with software product companies, and most of our engagements are partnership. We work with the clients' teams and integrate with the existing teams. And our professionals in Pune are very talented engineers, and our hiring process is highly selective, and our turnover rate is low. So you can expect, clients can expect good product delivery cycles, and the cost savings to our clients is approximately 50% compared to hiring locally in the U.S. And as an example, a snapshot of some of our current and past clients. Saqib, if you can go to the next slide. I think it's 25. I know it's probably hard to read, but some of our current clients, Saqib is aware of is PDX here in Fort Worth, Texas, Google, Halliburton, and so that's pretty much it for SynerZip. I'm going to start asking the questions now, Saqib. Let me start with the top. So I think you addressed the data security question. The question is about personally identifiable information from a centralized data storage perspective. So the question is, we might want the PII data to be scrubbed while it's being used by the dev cluster, but are fine with that data in the prod cluster. How do you handle that kind of data? You had mentioned.
So PII data is interesting. We are working towards handling PII data. I think right now we can handle PHI data, which is personal healthcare information, not PII data. We have just gone through our HIPAA compliance. So we don't typically handle PII data yet. And it's just one of those things where we haven't gone through yet. However, the way I see it is that typically in terms of access, have access to your data. You do. We cannot see that data. We cannot see that data at all because we have end-to-end encryption. So from our perspective, you have access to that data. What you do in terms of scrubbing is basically, at the end of the day, your business. And if you can connect a tool to scrub it out, great. We do not, as a service, have access to your data, so we can't see it, so we can't scrub it. And it's stored encrypted. And in many cases, in some of the cases, we can even enable you to hold the keys for it.
Okay. Thank you. So one of the questions, it's a follow-up to the data, virtual data mart question that came before. So, or rather, it is a cluster, basically a data warehouse, and you said no, not really, but it's more like a virtual data mart, if that's correct. And there is another follow-up that they're asking for more information. They think that it's not a big difference between data marts and the Snowflake multi-clusters. Are there any write-ups or white papers that?
Yeah, absolutely. So that's a great question, and you can go to our website, snowflake.net/resources, and you can go and see a lot of our white papers and stuff. The basic difference between a data mart and the virtual warehouse is that in the virtual warehouse, you're not replicating the data. A data mart, you are still creating multiple copies of the data. In a virtual warehouse, that is just basically the compute, and it is connecting to a singular source of the data, a single access instance of the data. So whether you spin up different warehouses, what we have done is we separated out the compute from the storage itself. And so when you spin up virtual warehouses, you're still connecting to the single source of the data. While in data marts, you're separating the data out itself. And so you're storing different sets of the data. Sometimes it's aggregated data, sometimes it's chopped off data, sometimes it might just be a certain history of the data. And you're doing it for different purposes. While the warehouse can be done for different purposes, it still connects. A virtual warehouse inside a Snowflake environment can be for different purposes. It still connects to the same data store. And that is what is important, because that means that you still have the singular version of the data. And that is what we enable. So absolutely, you can go to snowflake.net/resources and go check out our white papers and stuff. We'd be more than happy to, for example, follow up with you and answer that question too, and show you how it's separate.
That would be great. I think that's what the audience member was requesting.
Yep.
So thanks. Yeah. So next question is, any specific reason for selecting AWS versus other cloud-based providers?
That's a great question, and we like to do two things. First of all, we like to state that Snowflake itself is cloud agnostic. However, if you look at the realities of cloud, and the economies of it, the number one cloud provider in the world right now is Amazon. And we have a great working relationship with Amazon. It's not to say that we won't have a great working relationship with others, but when we started out, most of the customers are deployed inside Amazon. So that's one of the advantages of doing it. Will we in the future go to other cloud providers? Possibly, but it all depends on the economies of it.
Okay, that makes sense. Next question is this solution available for on-premises?
That's a great question. And no, the answer is no. Unfortunately, we cannot provide it for on-premises. We only provide it as a service. However, we see a lot of customers ask that question, and then when we show the type of performance we can, even using the cloud, they get convinced about using it up in the cloud. It's kind of like using a service, right? Or like Salesforce, for example. You don't deploy Salesforce on your premise. In Snowflake too, you don't deploy that on your premise. It's delivered to you as a service, and you don't have to cater for it.
Okay, thanks. And the next question is, does Snowflake offer the complete cycle of ETL using cloud technology for big data?
So that one would probably need a little bit more description from the person asking the question. However, we exist in an environment where you can use our tools to upload data, or you can use our partners such as Informatica, Talent, Fivetran to perform the ETL. Now, depending upon what your workload is or what is your requirement, we'd have to look at what you define as a complete cycle of ETL. However, you can definitely load data through our load tools. However, we also work with different partners, and you can connect through different cloud offers to perform ETL and connect data sources to Snowflake.
Okay. I think, as you said, Saqib, it might need a more understand more in-depth answer. So audience members, feel free to reach out to Saqib, and that will be in his contact information will be in the email that will be sent to you, or it's also in the presentation slide that's being displayed at this point. So. So moving on to the next one, is Snowflake open source?
No, it's not open source. It's proprietary, developed by people at Snowflake. And our history goes that about 3.5 years ago, a couple of folks from Oracle, Teradata, IBM, and other big providers of analytics decided that, hey, we wanted a solution which made sense for the modern world. It was not just legacy environments or building on top of something. We wanted something which is more pertinent for the cloud world, for combining all this data together. So that's why we built Snowflake, and we built it from the ground up. And we built it in such a way that we can accommodate all different sorts of data and provide the elasticity and the scalability of the cloud. So no, it's not open source. It's proprietary.
Okay. How is it different compared to Amazon EMR? I think these are.
I think Amazon EMR basically is used for semi-structured. And the thing is, at the end of the day, this is a completely different environment in itself, because frankly, we are combining not only semi-structured data but also structured data. And you have the ability to query it with using just standard SQL tools or BI tools, while you can also connect through JDBC and ODBC. So I hope that answers your question, but I would have to look at what is your specific requirement and how you're using EM.
Yeah. Sorry, in terms of elasticity. In terms of elasticity.
So we'd have to look into how you're using it and then determine how it's different for you in terms of elasticity. It's a little bit of a double. We'd have to talk to you first before understanding what is your requirement on that one.
Okay. Snowflake, there are lots of questions, so I'm rushing. Sorry, Saqib.
Sure.
Is Snowflake available in Azure?
No, it's not. Right now, we are only available in Amazon Cloud.
Okay. Okay. Could Snowflake be implemented in a container as well?
Well, you could possibly look into that. Well, the thing is, we do not implement it in a container environment. It's provided as a service. So I think you could potentially connect it using containers, using connectors from a container, but you're not. You could not implement it or in a container environment, inside a container environment itself.
Okay, thanks. Next is SAS Analytics supported?
SAS Analytics. If you're connecting through a JDBC and ODBC driver, yes. You can connect through the standard JDBC and ODBC drivers. I'm not too cognizant of SAS Analytics myself, but I think they basically, all of these analytics tools connect through one or the other, ODBC or JDBC. So I would have to check, and I can get back to the person who's asking that question. but absolutely, we can connect through JDBC and ODBC through most of the major tools. In fact, some of the major tools, a lot of the major tools actually have native connectors to Snowflake itself.
Okay, thanks. So kind of a follow-up, actually follow-up, one of the questions is, can cloned dev instances have data masking applied? And I think there was conversation about, cloning it and applying masking software. Scrubbing software.
Scrubbing software. That's actually a very interesting question, and I would probably have to take it to somebody more technical than myself inside my organization to try to answer that. So if the person who's asking this question would like to get in touch, we can definitely follow on with these this question, because I would have to understand how masking would work and how they are doing masking to be able to do that.
Right. I think the context is that dev teams, you don't want dev teams handling production data. So okay. So
so we'd have to see like how is that different from like assuring some sort of access control versus how much masking needs to be done of the data itself. So let's take that conversation offline and we can follow up with the person too.
Okay, sounds good. One of the questions that seems to be recurring is pricing information. What is the best way to address that? Should they just contact you?
They can contact us. They can go to our website and fill out a form for pricing information. We can take their information and contact them too. So that's pretty easy. We can get back to them really quickly. And in the future, we have thought about how we are going to express pricing, but we have certain pricing parameters. Basically, pricing is based on your consumption of storage and how much warehouse you use and what time you're using it at. That's about it. If you shut down a warehouse, you'll not be charged for a warehouse. If you're operating a warehouse, you'll be charged for the warehouse. So that's about it. And we base it on consumption. So.
Okay. So the next question may involve a little bit more. It's more involved, I think. It's the audience member is asking, how does one think about getting off of a legacy based, appliance-based, application-based data warehouse solution?
That's a great question, and I've seen so many examples of our customers pulling us into that discussion that, hey, we have this legacy platform. And I'll just give you an example of a customer we talked to in the financial insurance sector a few months back. And they are an existing customer. We have their reference and stuff. But basically, they had an appliance. They brought us in. We are ANSI SQL standard, so your SQL translates very easily into our SQL, so migration's easy. We work with organizations such as Synerzip, for example, to help customers migrate. We also provide solution engineers who help you migrate. And then at the end of the day, we fit inside the whole ecosystem, so you don't have to cater for, you don't have to change significantly on your BI end or your ETL end. We just fit and replace that appliance. And it's a very interesting use case which we are seeing more and more that, basically customers thinking outside the appliance box, right, is that they're thinking they do not want to do any more stuff inside the box. They don't want to cater for the appliance. So that's one of the things where we're seeing very actively our customers challenge that we don't want the appliance anymore. And in terms of performance, I've seen customers again and again state, like, we are beating performance metrics on those appliances. And the thing about appliances is if you look at the history of appliances were created for some very specific use cases. And those use cases are older. And they're more and more being used as data marts rather than actual data or complete data warehouses. So Short answer, yes, we can very easily migrate you off your appliance and get you running in Snowflake.
Great, thank you. I think this is a follow-up to a previous question about ETL. So how, the question is, what about the transformation, the T in the ETL? How is that?
Yeah, so you can use the standard tools like Informatica Talent for transformation. Depending on your transformation needs, what are you doing with transformation? We'd have to understand that. There's, depending on how you're transforming it, we'd have to look at that. Some customers do tend to use parts of their data warehouse for transformation too. It really depends on what is your exact need from that ETL. And you can do that transformation inside Snowflake, or you can use tools to do that transformation too.
Okay, thank you. This one is slightly more technical question. Is variant a column data type or a table type? You said table type.
Yeah, so it's basically a column data type, and our database itself is a columnar-based database. So it's basic columns which are being stored, and inside the variant, what Snowflake basically does is that it stores all that data in multiple columns. So let's say if you got 3 fields like we did in the example, you would get 3 columns. But those 3 columns are hidden from the customers. The customer only sees 1 column, which is the variant data type. And you can basically query, going back to the example, you can basically query from that using sub-column notation. So you can say name.city. State. And if you were expressing address, apartment number or telephone number dot whatever. And you can even perform joins on that column. So at the end of the day, we are a columnar-based database. It's a column data type, and you can easily use it that way. And all of this is done in the background for you. You don't have to do any of the multiple column declarations and stuff.
Okay, great. Next question is there any, what's the comparison between ownership, cost of ownership between Hadoop and Snowflake? Any rough numbers of?
That's a great question. So I don't have any specific numbers, but let me point it out to you this way. People say that Hadoop is open source, but you have companies like Hortonworks or others building businesses around providing services for Hadoop. At the end of the day, I've heard from so many customers that they started out with Hadoop. They had to hire so many engineers to deploy it and not drive business value that they gave up on Hadoop. And that's why, in terms of a 10-year-old technology, it still feels like it's still not a mature ecosystem. While on our end, for example, a lot of customers use us, and when they start comparing the benefits they get, the easy access of data for the analyst and the time to market, they're very impressed by those sort of things. On top of it, the fact is that we are very elastic and scalable. So let's say if your organization is 9 to 5 and has 4 people, you can run the warehouses from 9 to 5 and then shut them off and not pay for anything after that. Or if you wanted to run one query afterwards, then you don't have to pay for it. You don't have to, you only pay for what you run or consume, nothing else, right? So those are some of the things which are very important. And I think that all adds towards the TCO. Plus the fact that, you have to maintain Java programmers or administrators or things like that, while on Snowflake, all of that is done for you.
Okay, there are just a couple, unfortunately we run out of time. There were just a couple more questions, but I think we need to wrap it up now.
Yeah. And, so, I encourage the audience to ask me any questions over email, follow us at SnowflakeDB or follow us on our website and stuff. That's very encouraged. Get in touch with us, get to know us. we are really here to help you out, seek that information, and if there's any questions, I do feel like there were some questions which were not answered completely, and so let's get back to them, and let's hear from the customers too.
Yep. Thank you so much, Saqib. This was a great session based on the questions, the range of questions we had. So really appreciate all the hard work and a great presentation. And thank you, audience, for joining us today. And look forward to.
And thank you for Synerzip, Ranjani, and Jill, and every one of the audiences for participating in here and asking the questions. We look forward to getting back to you with feedback. So thank you very much.
Thank you all. Bye.